Hello students, this lesson is about dividing radicals. In example 1 we have the square root of 20 divided by the square root of 5. What you can do is anytime you are dividing two radicals you can combine them under one radical, so that would be the square root of 20 divided by 5. You can go ahead and divide 20 divided by 5, which gives you 4, so that's the square root of 4, and then the square root of 4 is plus or minus 2, and that is your answer. Okay, but what happens when you can't divide the numbers that are under the radical, like on this example 2 here? We have the square root of 7 divided by the square root of 3. If I put it under one radical, it's not going to help me because 7 divided by 3 is not a whole number. So there's something that we have to do here, and it's called rationalizing the denominator. So I'm going to write that down. Rationalize the denominator, okay? Because it's a rule in algebra that you cannot have a radical in the denominator. So what you're going to do is you're going to multiply the top and the bottom by whatever's in the denominator. So the denominator is the square root of 3, so we're going to multiply the top and the bottom by the square root of 3 over the square root of 3. The reason why we're doing that is because I'm not changing up my fraction, because the square root of 3 divided by the square root of 3 is equal to 1. So I'm not changing it up, I'm just multiplying by something that's equal to 1. The reason why I would want to do that, though, is because it ends up getting rid of my radical on the denominator. Because the square root of 3 times the square root of 3 is the square root of 9, and the square root of 9 is 3. So the radical just goes away. Now on top, you'd want to go ahead and multiply those two together. Square root of 7 times square root of 3 is the square root of 21. And square root of 21 breaks down to just be 7 times 3, which then you can't do anything with it. So this is your most simplified answer. Now one thing I want you to be careful of is don't try and cancel this 3 into the 21, because the 21 is under a radical. It's the square root of 21, and 3 is just a whole number. You can't cancel unless they are both under the radical. So let's just do a few more problems. So we have 6 divided by the radical 5. So let's go ahead and rationalize the radical, or rationalize the denominator, by multiplying the top and the bottom by that radical. And so on top we have 6 radical 5. So remember, you can't combine them unless they're both under the radical or both outside of the radical. And then on the bottom, square root 5 times square root 5 is just 5. The only way I could simplify this more is if the numbers that are on the outside of the radical could simplify, but 6 and 5 do not have anything in common. So that's my final answer. Okay, let's look at another one. We're going to have x squared over the square root of x. Okay, so we're going to have to multiply the top and the bottom by the square root of x. So on the top, we have x squared times radical x, and on the bottom, radical x times radical x is just x. And then because x squared and x, I can divide out one of those x's, then my final answer is just x times radical x. Okay, next 5x divided by radical 15x. Multiply the top and the bottom by radical 15x. And so on top we have 5x times radical 15x, and on the bottom we just have 15x. Okay, well 5 goes into 15 3 times, and I have these x's on the outside that will get canceled. So on the top I have the square root of 15x, and on the bottom you have 3. Again, be careful, don't make the 3 go into the 15 because one's under the radical and one is not. Okay, last two examples. Square root 11 divided by square root of 8. Now, even though we can break down the square root of 8, we always want to rationalize first So let's multiply the top by the square root of 8 and the bottom by the square root of 8. So on top I have the square root of 88, and then on the bottom you just have 8. Okay, now let's go ahead and break down the square root of 88. That is the same thing as the square root of 11 times 4 times 2. And of course 4 could get broken down also, but let's just leave it like that for right now. And then anything that you can simplify, go ahead and simplify. Well, we know that the square root of 4 is 2, so let's bring that to the outside. And then 11 doesn't break down any further, and 2 doesn't break down any further, so let's multiply those back together. 11 times 2 is 22. And then on the bottom we have 8. Well, because the numbers on the outside can simplify, 2 goes into 8 4 times. Now we have our final answer of the square root of 22 divided by 4. Okay, so I want you to make a note here. Always rationalize first, then reduce. Okay? Alright, let's try this last one. So we're going to rationalize by multiplying the top by the square root of 20 times x cubed, and then the bottom times the square root of 20 x cubed. Okay, so on the top we have 32 radical 20 x cubed, and on the bottom you would just have 20x cubed. Okay, so let's go ahead and break down our radical. I'm going to do it right here. So we have 32 radical. Now we can do 4 times 5, and then x cubed. Well, that would be x times x times x, and that's all over 20x cubed. Alright, so the square root of 4 is 2, so we're going to bring out a 2 for that. And then this gives me a pair of x's, so I'm also going to bring out an x. And those get multiplied on the outside times the 32. So 32 times 2 is 64. And then plus I have the x, so 64x. Radical. The only thing that's left over is the 5 and the x, so 5x. And then on the bottom I have 20x cubed. So we want to simplify anything that's on the outside. 4 will go into both of those numbers. 4 goes into 20 5 times. 4 goes into 64 16 times. And then we can divide out an x. We can divide out this x right here with one of these down here, so that would be x squared. And then now just rewrite it. So we have 16 radical 5x over 5x squared. And that is your final answer. Alright, sorry I lied. I do have a few more examples because we want to see what happens when you don't have a square root, but you have a cube root or a fourth root or even a fifth root. So let's look at another example. So I'm just say example. And we have 5 divided by the cubed root of 3. Now something I want you to keep in mind is that when you have a cube root, you're looking for a group of 3 of the same number. So on this one, to rationalize my denominator, I need to rationalize by the cubed root of 3 times 3, because then that will get me a pair of 3 3's, which will get rid of my cubed root. So the cubed root of 3 times 3, that's the same thing as the cubed root of 9. And so that's what you're rationalizing your denominator by. Okay, so on the top you're going to have 5 times the cube root of 9. And then on the bottom, because there's 3 3's, that gets rid of your cube root, and so you just have 3. Now don't don't make the mistake of taking the cube root of 9 and saying that's 3, because again, it's the cubed root, and so we'd want to be breaking it down to have a group of 3 of the same number. And since that doesn't break down with 3 of the same number, then that is our final answer. Okay, now let's see what happens when we have another one. Let's look at another one. So we have 2 divided by the cubed root of 16. Okay, so I want you to think about this. 16 could be broken down into 4 times 4. Now if I need a group of 3, then that means that I'm going to need to rationalize my denominator with another cubed root of 4, because then I'll have 3 4s, and that would get rid of my cube root. So I'm going to multiply the top and the bottom by the cube root of 4. So on top I have 2 cube root of 4, and on the bottom that would get rid of my cubed root, so I would have just 4. And now let's go ahead and simplify that. 2 goes into 4 2 times, so you have the cube root of 4 divided by 2, and that's as far as you can go. Alright, this really is the last one, so let's do this one. Okay, so for this one we're going to do the 4th root, so we're going to have 8 divided by the 4th root of 4. Okay, so I want you to keep in mind that 4 breaks down to be 2 times 2, but we need a group of 4 2's, so that means I'm going to have to rationalize the denominator with the 4th root of 2 times 2, and then that way that will give me my 4 pairs of 2. So I'm going to multiply the top by the 4th root of 4, and now let's go ahead and simplify that. So we have 8 times the 4th root of 4 divided by, this is going to cancel my radical, and so I'm just going to have a 2, and then let's go ahead and simplify it even more. 2 goes into 8 4 times, so we have 4 times the 4th root of 4. We have lots of 4's. Okay, and that is your final answer. Okay, guys, I know that this is a lot of skill and drill, but you really need to know how to do this to go forward and with what we're going to be doing next. So have a good evening and come to class ready to discuss and fill out your WISC and have your notes filled out as well.